This is video on kinematics of particles. This is 12th video in the series. Here we are dealing with collision of particles and we are trying to solve problems on oblique impact or oblique collision. This is second video on the problems. Okay, so here what's going to happen is the particle will move along, let's say, x-axis, and another particle will come and collide on it at an angle. Okay, and we want to solve problems of this type. So what is important in these problems is you must understand what is line of impact. So anytime when they collide or touch each other, you join the centers, that is line of impact. And our equations, our momentum equations are valid along the line of impact only. So we'll be writing these equations along line of impact. And perpendicular to line of impact, since there is no impact, there will not be any change of velocity. Now, these 3 points we have to use and remember while solving the problems, and they will become more clear as we go along with the problem. So let's take the first problem, which says two identical balls, each of mass m, collide with velocities as shown in figure. Find the final velocities of the balls after impact. Assume E to be 0.9. Now you see in these problems, it is advisable to write data little systematically. So let's say here is body A. Now initial velocity is associated with symbol U. So, and x-axis is I take along this 1.6 meters per second as x-axis, then you all will agree that u1x is 1.6 meters per second. Now, for body B, u2x, that is velocity of second body along x direction, will be minus 3 cos 45. Now we write u1y. I think we will agree that u1y is equal to 0. Because body A doesn't have any velocity in y direction, initial velocity. Similarly, u2y will be 3.5 sin 45. Now, our line of impact is along x-axis, and therefore our equations are valid along x-axis, and therefore we will be able to find v1x and v2x by applying our collision equations. And as far as v1y is concerned, because it is perpendicular to the line of impact, this v1y will be same as u1y, and so will be v2y, which will be same as u2y. So, having understood this information, let's solve for v1x and v2x by writing our equations, wherein you will note that both these equations are written in x direction only, because the impact is in x direction. So if you put in the numbers, and since all masses are same, these m's will cancel out, and we will be able to solve for v1x and v2x. And if we do that, we will get v1 and v2 as this, that is minus 2.27, and v2 as 2.84. Now we have to just remember that when I am working out v1, I will get from these two answer for v1x. v1y is 0. So final velocity is actually v1x square plus v1y square under root. v1y is 0, so v1x will its magnitude will match with v1. But when we are working out v2, we will get from these two equations v2x. We will have to do v2x square plus v2y square, take under root, and then we will get this value of v2. So thus For this oblique impact, by writing data systematically, we have worked out V1 and V2, that is final velocities of these two particles after the impact. Let's see one more problem, which says two identical balls of 120 grams collide when they are moving with velocity perpendicular to each other as shown in figure. Assuming that the line of impact is in direction of motion of ball B, determine the velocity of ball A and ball B completely after the impact. Take E as 0.8. So what we do, we take these bodies A and B and write out the data systematically. U1x, that is initial velocity of body A in x direction, is 2. Initial velocity of body B in x direction will be 0, so U2x is 0. U1y is 0 and U2y is 6. Now impact is along y-axis. They're given that. So there is no impact along x-axis, and therefore x direction final velocity will be unchanged. It will be same as U1x. So V1x will be same as U1x. V2x will be same as U2x, that will be 0. And to work out V1y and V2y, we will use our collision equations in y direction. Now if we solve this and work out the final velocity as before, we will get these answers. Thank you.